Alldus podcast is brought to you by Alldus International, supplying your expert AI and digital transformation staffing needs across the US and Europe. Today, you are listening to our AI in Action series, where leading minds in AI from across the world share their story, success, and advice. AI in Action cuts through the hype and explores the true impact of artificial intelligence in our world today.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is Ned Dimitrov. Ned is the VP of Data Science at StackAdapt. Ned, welcome to the show.
Thanks, JP, for having me.
Oh, it's our pleasure. So Ned, let's start with yourself. Can you give us a brief overview of your journey in technology, from where you got started, what initially drew you interested into this field, some of the roles you've held along the way, and take us up to just as you were about to join StackAdapt?
I started in technology back when I was an undergrad. So I did a double major in math and computer science. I was always interested in math, but I also took computer science because it was a novel thing. A lot of developments were happening there. And so it was different. It was an area that I was also interested in. And then when I went to grad school, I was trying to decide whether I should do my PhD in math or in computer science. And I decided computer science because it was a younger area, because there were more innovations going on there per unit time. A lot of the problems weren't 600 years old that people have thought about for a long time. There were newer problems, newer things to solve. And so that's why I picked computer science. But in terms of my journey, it always started with a very theoretical starting point and moved to a more and more practical applications over time. So I started with that math background, and I started doing the most mathematical of computer science theory. I did pseudo-randomness extraction, which was trying to create random numbers from pseudo-random numbers. And there's a lot of interesting theory over there, but it's very mathematical. And over time, I turned more into algorithms and solving problems that real world people care about. And so I had a number of influences throughout my career. One of them in particular was a professor in the operations research department in my university. So I learned about operations research during my PhD in computer science. It's an area that's reasonably old. It goes back to World War II, and it's all about optimizing military operations back in the day. So it's all about taking those real world decisions, modeling them with math, turning them into a math problem, solving the math problem, and letting that inform the actions in the real world. And I became quite interested in that. And so after my PhD, I did a postdoc in operations research, and then I was a professor in operations research for about 8 years in a couple of universities. One was the Naval Postgraduate School, which is a university inside of Department of Defense. Most of the students are mid-career military officers who go on to be analysts for the Pentagon after they get their degree. And then I was also a professor at the University of Texas at Austin in operations research. And ultimately, after a while in academia, I noticed that a lot of professors compete with each other on data. They compete with each other on what data they have access to. And that really limits the kind of research problems that they can access, because most companies don't want to share their data. It's a very private thing. It's a thing that gives them advantage in the marketplace. And that's why professors compete on data. And that's one of the reasons why I chose to switch to industry, is because companies, especially companies like StackAdapt, really don't have a problem with finding data. StackAdapt has so much data that most of the time we have to think of new ways of using it usefully, ways of downsampling it, ways of processing it in a computationally feasible manner. So the problem is too much data as opposed to too little, where it is in academia. And that gives me a lot of opportunity to do all kinds of really interesting research questions at StackAdapt.
Thank you for that overview, Ned. Really helps understand your journey, and it's great to talk to somebody who's very successfully made the transition from academia to industry, which we'll touch on a bit more later in the interview. But to help frame what you're doing currently as the VP of Data Science, tell us all about StackAdapt, who you are as a business, what the mission of the organization is, and then we can jump into your role as the VP of Data Science.
So StackAdapt is an advertising technology company. And just taking a step back, most listeners may not be familiar with this, but just to describe a little bit of the environment that StackAdapt operates in, when you go to a major website like CNN or New York Times, and the website shows you an advertisement, what actually happens in the time of about 100 milliseconds, so very fast in real time, immediately when you hit the website, there's an auction that gets run where thousands of advertisers bid for the opportunity to show you their advertisement. And the company that wins that auction is the one that actually gets to show you the ads. So StackAdapt participates in these auctions for our clients who are typically major brands or advertising agencies who want to show particular ads to online users. In the language of the industry, StackAdapt is what's called a demand-side platform. So it aggregates many advertisers who are the people, the demand side of the advertising industry. They're the ones who want to place the ads. And there's a mirror image of that that's called a supply-side platform that aggregates many websites. So it'll take websites like CNN, New York Times, various others that you might be familiar with, Reuters, etc. It'll aggregate all of the bid requests from all those websites and put them into one sort of data pipeline of bid requests. So those are the supply side platforms, which are the mirror image of the demand side platforms in the advertising industry.
That's really helpful. So moving into yourself and your role, I know you joined the business in 2017 as a director and have since been promoted into VP. Can you walk us through that journey, and then what are some of the responsibilities that you have as leading the data science group?
So in terms of the kinds of responsibilities for the data science team at StackAdapt, what happens at StackAdapt is a tremendous amount of algorithms innovation. There's a lot of real world problems that we're trying to solve in terms of delivering advertisements to our clients that actually perform, advertisements that get traffic to their websites, that sell the products that they want to sell, and so forth. So I can give just a few example problems of this. One of them is when you receive a request to participate in an auction, you very quickly have to determine what is the likelihood of the user engaging with an advertisement you're thinking about showing. And the reason is that the major brands, they want to show their ads to users who engage with it. They want the user to click, maybe read the landing page, maybe purchase a product. And so the more likely the user is to engage, the more valuable the auction is to the client. And that ultimately affects the kind of bid you want to place in that auction. So that's a typical kind of data science problem in the advertising industry. But you could break down the problems into a couple of problems. One is performance, making sure that the ads choices that you make give performance to the client. And another is targeting, making sure that those ads are shown to users who are likely to be interested in the product so that there isn't a lot of waste in the advertising deployment. And in terms of the journey at StackAdapt, I would say I've been at StackAdapt for a number of years, and our data science products have matured significantly in that time. So many of the projects, for example, we have a project on lookalikes, which is if we have a client that's selling t-shirts, we'll look for users who look like they might be interested in selling t-shirts so that we can show them advertisements. So this project started with one version several years ago, and now it looks completely different. It's a much more sophisticated, much more difficult for a new person to pick up because of all the nuances that are entered into the algorithms and into the pipelines. And that's the typical kind of development at StackAdapt. Is typically things will start with a lot of algorithm innovation, but that algorithm innovation doesn't stop along the way. It's continuous over time until ultimately something very sophisticated is produced and put into production.
You are listening to the Alldus podcast. When you're looking to scale your team, or if you are interested in showcasing your company in a future episode, reach out today. Or if you're in the market for a new role, visit our website to view open positions, www.alldus.com.
Ned, if you look at your team currently and the makeup of the group and some of the day-to-day work, what is a typical project life cycle look like for you, and can you give us some insight into the various elements that are involved to achieve the end result, a combination of the engineering, data science, machine learning, analytics, all the elements that make up a typical project?
Yeah, sure. Typically, a project starts with an idea, and usually it's a common sense idea, something like, oh, it would be really nice to be able to do this automatically, or this information seems like it should be useful for making this decision. And this idea sometimes comes from the data science team, and sometimes it comes from other teams. Oftentimes it comes from sales, it can come from product, it can come from the tech team. Almost anyone can have these ideas because ultimately they don't need to be a data scientist to create them. They just have to know the industry well and have a strong intuition about something that should work. And so those strong intuitions are usually what start a project at the beginning. So once a project is started, it gets prioritized along with other projects. And once it gets picked up for development, typically a data scientist would start with the project. And at that point, we would use the massive amounts of historical data that StackAdapt has access to do a lot of historical backtesting. So this is the point at which data science skills really come into play. So this is the point where we do things like figure out what are the right metrics for the project. How do we use our historical data, which might be biased, and know the best way to evaluate the potential algorithms so that we don't introduce bias into the evaluation? How do we create algorithms that have the appropriate amount of computational efficiency to be put into production? So all of these questions in algorithm creation and historical backtesting is primarily done by the data scientists at Stack. After the data scientist identifies a promising algorithm, and typically this happens after many iterations over potential algorithms, but after a promising algorithm is identified, typically they'll partner with a data engineer. And the data engineers are critical in implementing the vast distributed systems that execute our machine learning algorithms. So just to give a little bit of statistics, typical kinds of distributed systems at StackAdapt, our databases oftentimes have to handle on the order of 3 million queries per second. We have to multiple machines processing things in parallel. And oftentimes our machine learning algorithms have to execute within a millisecond. And the reason for that small time window is the fact that you have to reply to these auctions very quickly. Because if your reply is too slow, then your bid doesn't get considered regardless of what you bid, because the website wants to be fast loading. They don't want to wait too long for the bids to come in. So that puts another pressure on our data engineers in terms of writing really efficient code so that it executes well. So the data engineers are primarily the ones who design all of the data pipelines to feed into the algorithms, design all the distributed systems to serve the algorithm in real time, and oftentimes work with the data scientists to do algorithm iterations that maybe refine the algorithm in such a way as to make it ideal for putting in production, which might be significantly different than the version of the algorithm that the data scientists identified as promising in historical backtesting.
Fascinating stuff. And given the complexity and the data set side and the speed, it sounds like a fun challenge, which I know a lot of engineers and scientists will appreciate. As the head of the group there, the VP, you've been there while the team has grown, and you've been involved with the hiring process yourself. Obviously, in the field that we're working in, there's a lot of competition for good talent right now. I know that you've been successful in bringing in quite a few people. When you look at your process to identifying talent and more importantly, screening for the right type of fit, what is it that you look for?
So the screening process at StackAdapt looks for several things. So one of the things that's definitely a must for all candidates is just the ability to interact with others in a nice way in communication. So that's one of the things that interviewers often evaluate is, did this candidate communicate their ideas effectively? Did they understand the suggestions? Did they respond to suggestions well, as opposed to thinking of them as criticisms and reacting aggressively to those suggestions? So all of those things, they're not explicit interview questions, but they're things that the interviewers pick up on as they're talking with you and make a big difference in terms of their opinion at the end of the interview as to whether to bring someone into the company or not. Because ultimately at StackAdapt, we're looking for people who are highly capable, but also really nice and really capable of interacting with others across a variety of subjects. So that's one part, is communication. Another part is just technical competence. So this is something that everyone is familiar with. In the StackAdapt interview process, we ask a lot of very sophisticated questions that we've come up with ourselves through our practice, different algorithm designs that come up in our actual problem solving. And that is something that filters a lot of candidates, is basically their ability to answer in a dynamic way, in a way that applies all of their knowledge in a flexible manner to new problems that they've never seen before. And so I'm not talking about just lead code problems here. So not just a database of problems that you can access and apply your knowledge to and train on, but also just new problems that you've never seen before. How do you approach this new problem? What are your general problem-solving tools. And being able to access a wide variety of tools to solve a problem and being able to communicate about those tools effectively and use them makes a big difference in candidate interviews.
Ned, you've already given some insight into what is unique at StackAdapt, particularly with the complexity of the problem. But when you look at the work you're doing and the impact that it can have for your customers, speaking to an audience of people who are interested in this field, what would you tell them to get them excited about the work at StackAdapt over some of the other organizations that they're potentially considering?
I would say StackAdapt is really a leader in AI-based advertising. It's been one of the company's founding tenets from the beginning that we want to automate a lot of the decision-making, whereas many other companies, their approach is to allow the user lots of levers where they can micro-optimize and micromanage their own advertising campaigns. At StackAdapt, we really look to leverage the power of data science and AI and decision-making and automated decision-making to make it so that the campaigns automatically perform well for the client without the client having to do major improvements on the campaign over time. It's more of an automatic optimization based on the data as opposed to manual optimization.
Really helpful. Final question for me then, Ned. Obviously, you've been with StackAdapt for several years now, and you're seeing the growth of the business and the sort of change in the advertising industry as a whole. When you look ahead, what's next for StackAdapt and this space? What are you most excited about?
I'm most excited about some of the recent developments in the advertising industry. So one of the recent developments is that privacy is becoming a greater and greater concern. Many people use ad blockers, and there's a lot of legal things that pass, like, for example, the General Data Protection Regulation in Europe that protects people's online information from advertisers so they cannot advertise based on it. And this has switched focus in the advertising industry. It's particularly at StackAdapt, we have a large focus on contextual advertising. So this is using natural language processing to determine that this particular website content is the right content in which to show the ad. So that yielded a number of novel algorithms at StackAdapt for contextual advertising that nobody else has, that really give us an edge on the competition in terms of the ability to adapt to a changing marketplace and the ability to attract new talent by offering the opportunity to work on really cutting edge algorithms in terms of natural language processing.
Ned, thank you so much for coming on today and talking to us, sharing your own story, giving us some insight into StackAdapt. It sounds incredible what you're able to do there, and it sounds like a fun place for engineers and scientists. And we're excited to see what you and your team can accomplish in the years ahead. So thank you again.
Thank you for having me. It was my pleasure.
Thanks for listening to this episode of the Alldus Podcast. If you enjoyed today's episode, don't forget to subscribe, rate, and review. We are available on Apple Podcasts, Spotify, and any Android podcast of choice. You can also head over to our website, www.alldus.com, to listen to more podcasts, view our open roles, and stay up to date with industry news. Thanks for listening, and stay tuned for more great episodes coming very soon.